OpenAI just announced it's building its own AI chip. Google's been doing it secretly for years. Meta, Microsoft, Amazon, even SpaceX, they're all pouring billions into chip design. 2 years ago, basically none of them were. Nvidia had total dominance. Now they're facing competition from the biggest AI companies on Earth. Here's what's wild. Why would OpenAI need chips when Nvidia exists? The answer completely changes how you think about AI's future. Building a chip isn't like a car company making engines. It's owning your own power plant instead of buying electricity. When you're training massive language models that cost millions per run, a 1% efficiency gain saves hundreds of thousands of dollars every single time. Nvidia charges premiums because they're the only real option. If you're OpenAI or Google, you choose. Keep paying Nvidia forever, or spend billions to build something cheaper and faster. The stakes are enormous. We are talking about reshaping the entire AI infrastructure market. What happens in 2026 might determine who owns AI for the next decade. The first question everyone asks, can these companies pull this off? Chip design isn't like software. It's one of the hardest engineering problems on Earth. You can't iterate quickly. You can't patch it. If your design has a flaw, you've wasted billions and years of work. Nvidia spent decades perfecting their approach. These new challengers are trying to leapfrog that expertise in just a few years. And here's where things get interesting. To understand why companies are suddenly building chips, you need to know how Nvidia dominated in the first place. 5 years ago, Nvidia's graphics processors, GPUs, were repurposed for AI training. They were never designed for it. Made for video games, but incredibly good at the parallel processing AI needs. Nvidia pivoted hard into AI. They invested billions improving their chips specifically for machine learning. By the early 2020s, if you wanted to train a large language model, you basically needed Nvidia GPUs. There was no real alternative. Google tried making their own chips, TPU, but they only worked for Google. Everyone else bought Nvidia. This created massive supply shortages. During 2022-2023 AI boom, Nvidia H100 GPUs were worth their weight in gold. Data centers waited months for shipments. Companies paid premiums just to get a chip. Nvidia became irreplaceable. Here's what most coverage gets wrong. Nvidia didn't win through ruthless tactics. They won because they had the best engineering team, moved fastest, and got lucky with timing. But that luck is running out. The bottleneck Nvidia created is becoming unbearable for OpenAI and others. They're not just frustrated with supply, they are frustrated with cost. An Nvidia H100 costs around $40,000. To train a single large model, you might need thousands of them. The bill adds up to hundreds of millions of dollars. That's the real pressure point. And this is just the beginning. Think of an AI chip like a factory floor. More workers means more products. Faster workers means quicker completion. A GPU is thousands of tiny workers running the same task simultaneously. That's why they are so good for AI. But here's the thing, not all workers need to be equally fast. Some parts of AI training don't need cutting-edge speed. They need efficiency, doing work without burning tons of power. Nvidia's H100 prioritizes pure speed. It's optimized for one thing, run calculations as fast as possible. It costs money to run, generates heat, needs specialized cooling. What if you built a chip with different trade-offs? Something 80% as fast but using half the power? That's a game changer. Training a model isn't just about raw speed, it's about total cost. If your chip costs less to run, you save money on electricity and cooling. Suddenly you're competing with Nvidia. There's another angle. Nvidia makes general-purpose chips for everyone. But if OpenAI builds a chip optimized specifically for their models, it could be way more efficient. It's like building a delivery truck optimized for your specific routes versus buying one designed to go anywhere. That's the strategy here. Nobody believes they'll beat Nvidia on pure engineering talent overnight. It's that specialization creates advantages Nvidia can never match. They have to serve everyone. The thing is, this strategy has already started working. Multiple companies are shipping chips right now, and some early results are genuinely surprising. Who's building these chips? OpenAI's working on Strawberry, their own custom processor. Google's been running TPU-5 and TPU-6 for years, specially designed for their models. They don't sell them publicly, they keep them in-house. Meta is building chips. They call it M-tier, Meta Training and Inference Accelerator, designed specifically for their recommender systems and language models. Microsoft's investing in custom silicon. Amazon built Trainium and Inferentia chips. Even Tesla is building chips for autonomous driving. SpaceX is in the mix too. Custom processors for satellite communications and onboard AI. These companies all realize the same thing. At scale, custom chips give you an edge. But here's where it gets interesting. These chips are shipping. Google's TPU-6 is already running production models. OpenAI's Strawberry is in development. When they hit the market in the next year or two, they won't replace Nvidia entirely, but they'll carve out a significant chunk. Think about it this way. If you're Google and you save 50% on compute costs using your own chips instead of Nvidia's, you do it. Google has enough scale that even a 1% efficiency improvement means massive savings. Same goes for Meta, Amazon, and Microsoft. These companies don't need Nvidia anymore. They're just now realizing it. That's what's shaking the market. And the really jaw-dropping part is what happens next. On paper, Nvidia H100 has a peak performance of about 1,500 teraflops. That's a trillion floating-point operations per second. Sounds theoretical, but in AI training, teraflops translates directly to speed. Google's TPU-6 hits similar numbers, around 1,400 teraflops, but with way better energy efficiency. It uses significantly less power to do the same job. Here's the kicker. Energy efficiency actually matters more than raw performance for companies running models constantly. If you're saving 30 or 40% on power costs, that's real money. An A100 GPU costs roughly $40,000. A TPU lease for the same performance costs substantially less when you factor in power and cooling. But it's not just TPUs versus H100. The emerging chips from smaller companies are different again. Some are trading a bit of speed for massive efficiency gains. Others are specialized for specific workloads, inference rather than training, or vice versa. Here's what the benchmarks don't show: real-world performance in production systems. A chip might score perfectly on synthetic tests, but underperform in the actual models companies use. That's why we're not seeing a sudden drop-off in H100 sales. Companies want proof of concept before they bet billions. The game is still wide open. Nvidia isn't going anywhere soon, but for the first time, they've got legitimate competition in their core business. And that changes everything about how companies build their infrastructure. Here's the thing that changes everything. If Google and OpenAI successfully use custom chips at scale, the implications are staggering. Nvidia's TIM, their total addressable market, just shrinks. Instead of selling to every AI company globally, they are selling to everyone except the hyperscalers, massive cloud companies that build custom silicon. That sounds minor. It's not. Hyperscalers represent 60 to 70% of AI compute spending. If Google, Microsoft, Amazon, and Meta move 10% of their workloads to custom chips, that's a $10 to $15 billion reduction in GPU sales. Transformative. But here's what's really interesting. New companies emerge. Supply chains for custom chips need new partners. Design firms, fab capacity, software engineers, verification experts, entire ecosystems pop up. A startup custom chip firm could become as valuable as Nvidia, just serving different customers. There's a geopolitical angle too. The United States has been concerned about export controls on advanced chips. If countries build their own instead of buying American ones, that changes power dynamics. China invests heavily in custom AI silicon, so does the European Union. The chip war becomes a front in the larger AI war between nations. And then Nvidia responds. Do they fight to keep prices low, innovate faster, vertically integrate and become like Google, both chip maker and user? We don't know, but we are watching history happen right now. This is where it gets surprising. What should you be watching for? First, delivery timelines. When do these chips actually ship to production? Google's TPU-6 is already out. OpenAI's Strawberry is promised next year. Watch whether these companies hit targets or slip. Delays in custom chip manufacturing are legendary. Second, adoption metrics. Once available, how many models train on these new chips versus Nvidia GPUs? If Google uses TPUs for everything, that's a signal. If OpenAI uses Strawberry for 50% of training, that's validation. Watch the numbers. Third, scrutinize performance claims. Companies publish benchmarks showing their chips crushing Nvidia on specific tasks. That's probably true, but real-world production performance matters more. A chip might nail synthetic tests but struggle with actual workloads. Ask for production data, not just lab numbers. Fourth, watch the software. Chips are only as good as their software. Nvidia has CUDA 15 years of infrastructure and libraries. New chips need ecosystems. OpenAI rebuilds software stack for Strawberry. That's where delays happen. Software is harder than hardware. Fifth, Nvidia's response. Do they cut prices, innovate faster, partner instead of compete? Nvidia's move determines whether this moment sticks or fizzles. A company dominating for 15 years doesn't disappear overnight. But they can lose their stranglehold. So watch what Nvidia does next. Here's what the headlines aren't telling you. This is the biggest AI infrastructure reshaping in a decade. What started as Nvidia owning every GPU sale is ending with every major tech company building their own. A complete inversion of 15 years. For most people, this doesn't directly change anything tomorrow. You're not building chips, but it affects you. Companies cutting chip costs means faster innovation. Faster innovation means AI features arrive quicker, more powerful, cheaper to use. Think smartphones. When carriers built their own networks, they competed aggressively. Innovation accelerated, prices fell, features improved. Same thing happens to AI infrastructure. Multiple companies competing means better tools for everyone. There's a fairness angle too. For years, only the richest companies could afford Nvidia GPUs. Everyone else was locked out. Custom chips means startups compete on different hardware. The field tilts toward innovation instead of capital. Here's what changes for investors. Nvidia's reign as the inevitably dominant company is over. Not disappearing, they're a major player competing in a real market, not a gatekeeper controlling everything. That's a massive change. The next 2 to 3 years determine everything. Chips ship, companies test them, decisions get made. We're at the inflection point. So watch carefully, stay skeptical of benchmarks, and remember, the company controlling compute controls AI. That control is finally being challenged. Follow for daily AI news to stay ahead.